All right, today is the first stream. Um, so today we'll be doing valid parentheses and learning about stacks. So onto the neat code stacks. Just in general, I just want to learn it. Stacks. Oopsies. Structure stacks. Are these data structures or algorithms?
From this presentation onwards, we are starting with this new chapter called stacks, and in this particular presentation, I will introduce you to the concepts of stacks. So without any further delay, let's get started. Here is the outline of this presentation. First, we will look into the definition of stack, what a stack is all about. Then we will look into some real life examples of stacks. And then after that, we will look into what is a stack as an ADT, that is abstract data type. And finally, it is important for us to look into some stack operations, including primary and secondary operations. So without any further delay, let's move on. Here is the definition of stack. A stack is a linear data structure in which insertions and deletions are allowed only at the end, called the top of the stack. Okay. First of all, I want you to note this, that stack is a linear data structure, just like array or linked list. Okay. So stack is no different. Stack is a linear data structure, but insertions and deletions are allowed only at the end in case of stack, right? We know that insertions and deletions are allowed anywhere in case of array and linked list, but here when we talk about a stack, then insertions and deletions are allowed only at the end, called the top of the stack. Okay. So when we try to imagine a stack, we can imagine it like stack of books, or we could have a stack of coins, right? These two are real life examples of stacks. You can see that if we want to place a book, we usually place it at the top. And if we want to access a book, we usually access the topmost book, right? Similar to the stack of coins, if you want to access a coin, the easiest possible way is to access the topmost coin. Or if we want to insert a coin, we can insert a coin at the topmost place. It is easier, right? Obviously, these two are the examples of stacks. Now, in both these examples, there are two things which are common. First is, any object, either book or a coin, can be accessed only from the top. And second thing is, any object can be added only at the top. Now you might be wondering, or you might ask this question, it is possible to access the chemistry book before accessing the physics book. Obviously you might argue this. I can access chemistry book before accessing physics book, or I can access mathematics book before accessing these two books. It might also be possible that I can access this particular coin before accessing this coin, right? Or maybe I can add a new coin in between in these two places maybe. This is possible, right? But I want you to imagine a stack like this, where the objects are placed inside the glass jar. So here you can imagine a stack of books has been placed inside a glass jar. And you can also imagine a stack of coins has been placed inside a glass jar. Now it would be nearly impossible for you to access the chemistry book before accessing the physics book, isn't that so? Now it is easier to imagine a stack, right? So you can imagine a stack as a glass jar, and the objects are placed inside the glass jar. Now you're allowed to access the data only from the top, and you're also allowed to add the data only at the top. Okay, there is no other way. Obviously, glass jar is closed at the bottom, right? You can see this, but it is opened at the top. Therefore, there is only one way to insert or delete an object from the stack, right? There is only one way. Now, I want you to understand what is stack as an ADT, that is abstract data type. When we define a stack as an ADT or abstract data type, then we are only interested in knowing the stack operations from the user point of view, okay? So when we define a stack as an ADT, we are only interested in knowing the stack operations from the user point of view. Obviously, user is not interested in knowing the implementation details, right? User is only interested in knowing what type of operations we can perform on stack. That is what I want you to imagine. So when we try to define a stack as an ADT, we'll only try to understand what type of operations can be performed on the stack. This simply means we are not interested in knowing the implementation details at this moment. We are only interested in knowing what type of operations we can perform on stack. Okay, only what type of operations. We are not interested in knowing how these operations are performed, right? Now, we will look into some primary and secondary operations which are supported in case of stack. Let's look into one primary operation, that is push operation, which actually allows us to insert data onto stack. So imagine a stack like this, a glass jar, okay? And this is the data I want to insert inside the stack. So I'll simply use this push operation, and I can simply insert this data after using this push operation inside the stack. This is how it will get inserted. So imagine a data is placed over here and we just want to move this inside the stack, then we have to call this push operation. It will simply insert data onto stack, okay? Now the second primary operation is pop operation. It simply deletes the last inserted element from the stack, as simple as that, okay? So here is the stack and this is the last inserted element in the stack. So it simply deletes this data, or it simply moves this data outside the stack, okay? This is how it looks like, right? This is how you can imagine. Now, there are some secondary stack operations as well, like top, which simply returns the last inserted element without removing it. So imagine a stack like this, and here in the stack we have all these elements. We have these 3 elements inside the stack, 1, 2 and 3, where 3 is the topmost element. This top operation simply returns the last inserted element without removing it, okay? So imagine a pointer is pointing to this particular element, then it simply returns this element without removing it, okay?
Okay.
Then we have the size operation. It simply returns the size or the number of elements in the stack.
So in that case,
if we
3.
have 3 elements inside the stack, then size will obviously be 3, right? Then we have this isEmpty function. It simply returns true if the stack is empty, else it returns false. As the name itself suggests, isEmpty, right? It returns true if the stack is empty, else it returns false. So imagine a stack like this. Now, I would like to ask this question, is stack empty? Obviously it is not, right? You will say no, stack is not empty. Similarly, we have this isFull function, which simply returns true if the stack is full, else it returns false. So imagine a stack like this. Now I would like to tell you that this stack is
Okay, but how would you code that? Let's just jump right into it, to be honest with you. Oh my god. Alright. I say. So you were given a string consisting of following characters. It could be any of these. The input string S is valid only if and only if every open bracket is closed by the same type of closed bracket. Ooh, I see. But how does stacks come in hand in this? Okay, so every open bracket is closed by the same type of closed bracket. Every open bracket. So every open bracket is closed by its same type, makes sense. Open brackets are closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. Makes sense. This makes sense. Okay. So we're gonna ignore this atrocious code we did over here. I did, but I uninstalled it. It doesn't matter though. Alright. So let's go to over here. Is valid. We have a string. We're returning a bool. So let's head up the logic board. Okay, so what is the easiest way of solving this problem? So let's look at each scenario and compare them. Let me set the lowest bracket. So we're going to be basically looping through every single character, right? So the first character we're going to look at in this scenario, let's look at the first scenario. We have an open bracket, right? So we know that the order of closing brackets needs to be of this. It needs to be the first order of the closing bracket needs to be the square bracket. So first things first that comes to mind is to separate opening brackets into like a list. So I should have like a list of open and close. I should have a different. I don't know if I should do a list or if I should do a hash set. Not that it matters. Okay. But basically, so look, how do we see this? Before I even think of the coding aspect, let me just look at it and think of how to, like how I would think about it and how I could translate that to a computer. So over here, I see that the first thing is a bracket parenthesis. So the first closing has to be bracket parenthesis. This is the first. The first open is a parenthesis bracket. The first one has to, or actually, I see the last one. So it's first and last. So that's how they're used. I could just see as like you push this, you push this, then you push this, then you're gonna have to do the reverse of that. So I'm gonna. It sounds stupid, but I'm actually locked in right now. Cause boom, 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 type thing. So how are stacks used in Python? Python. I could test out some things. All right. So if I do over here, like, let's say the string. All right. Let's say the string is this or this. It's more accurate. And I do x is equal to the list version, or I could do split version. I don't know what we're splitting. And then I can go over here and do print x. Interesting. Perfect. Okay. Now it's very interesting that I just noticed, right? Wait, give me a second. I'm gonna go to the washroom. I'm back. Let's speedrun this problem. So I'm gonna keep on experimenting. So if we have a list version and we could just do x dot top. I don't even know if that's how it works. How do they work? Okay. Collections DQ. So we have a stack. We append these things. We can pop them, right? Okay. Okay, okay, okay. Type thing, type thing. Let me just go ahead and do this. Let me do over here. It is DQ, whatever. And we append set values. I was gonna say that I noticed that whenever we do have, it's usually a pair, but they didn't explicitly say anything like that. Got there, 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 there. So open, open, close, close, right? So first things first, we want to make sure. It's not that hard, to be honest with you. It's a very simple problem that I just need to take some time and wrap my head around and think. Okay, so I'm gonna let my voices out loud. So these are the potential things we could have. So let me do that real quick. So I have parentheses is going to be equal to these jumps. Okay. This. Right. And there are both opening and closed ones. And I don't want to be the type of person that. Alright, so. Should I make it a tuple? Nah, that's too much. So, op, close. I have these jumps. Have open. Open. And open. And we are going to have a close. Close. And yet another close. Oopsies. Perfect. This looks pretty confusing visually. I wish there was different colors for like the quotation marks, but it's not that important. Okay, so we have our opening and closed lists. So what I wanted to do, right? So we have this string converted to a list. I don't know what this was supposed to teach me. You append a value. Okay, so let me see what stack does. You can empty it. So yeah, check if it's empty. Check the size. Ooh, I can like half the thing. Basically, time complexity. That's actually perfect. Okay, so basically, if I check the size, right? And I say, okay, if the size divided or mod 2 is not equal to 0, then we know that there is an imbalance. There should be pairs. So then we could just immediately return false. Let me do that real quick. That's actually really good. So this is a stack. Interesting. So now we have this, right? And I could say if x dot size mod 2 is not equal to 0, what do you mean there's no attribute? So they have Q, life of Q. There is a problem, and I understand he started a max size. That is stupid. Um, 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 um. I don't even need to do a lot, to be honest with you. If this is an impaired number, then we know that there is potentially it's invalid. So I don't need to do all that. I could just say quite simply if x dot length, I don't even need to do this. I can just do over here. If length of s not 2 is not equal to 0, then I'm just gonna print not valid. In this case, return false type shit. Where is top? Oh. But let's say now there is an extra here. Yes, sir. Yes, sir. Yes, sir. Okay, so I wouldn't say half the test cases, but like past half of them. So open brackets. So now I need to check if the first bracket corresponds to Okay. I see how stacks are useful now. So we have from Q, we make a stack life of Q.
In programming, we have a common data structure called stack, which resembles a stack of items in the real world. Imagine you have a stack of books. The last book
I get it.
example of that is your browser
I get it.
website, and then click the back button. At this point, the browser removes the item on top of the stack and then it will redirect us to the previous website. Now let's say we press the back button a couple more times, so we'll end up with an empty stack. At this point, the browser will disable the back button. This is how a stack works. Last in, first out. Now let me show you how to use a stack in Python. Basically, we can use a list object as a stack. So here I'm going to define a variable like browsing session and set it to an empty list. Now let's say the user navigates to website number 1. So we call browsing session.append method and add the address of the current website. Now let's say the user navigates to website number 2 and then 3.
Let me try something real quick. I just became a little enlightened. Let's see over here we have x is equal to a list, and we just say for I in open s. We're just gonna do what's up and character for every one of those characters and print x. What would happen then? Makes sense. Depends it.
Let's have a look at what we have in our stack. So we print it, and as you see, we have a list of 3 items. Now, when the user presses the back button, we should remove the last item in this list, right? How do we do it? We use the pop method. So we call browsing session.pop. This will remove the last item from the stack and return it. So we can get it here, but in this case, we're not going to use this value. Let me just print it on the terminal so you can see that. So 3 is removed from the stack. Now if we print our stack one more time,
It'll remove
print browsing session, you can see 3 is removed and we have only 2 items in our stack. So we need to take the user to the previous website, which is the item on top of the stack. And we can get that using a -1 index. Very easy. So back here, browsing session of -1. This returns the last item. So we print it. And I would like to add just a label for clarity, redirect. Let's look at the result. So when the user presses the back button, we redirect them to the previous website, which is website number 2. Now here we need to check if the stack is empty or not. If it becomes empty, we need to disable the back button. So that is very easy. Earlier in the course, I told you about the falsy values. So number 0, an empty string, an empty list, these are all falsy values. So if we apply the not operator to an empty list, we'll get the Boolean true. So to see if our stack is empty, we can simply write code like this. If not browsing session, then at this point we will disable the back button.
Wait, if not.
So let me recap.
That is interesting. So, if we follow the rules here, every open bracket is closed by the same type of close bracket. Open brackets are closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. They only say it's valid in these cases. If there's no brackets, then we just need to return false. If length of s is not mod 2 is not equal to 0, print is not pair. Print false. Okay. Interesting. So we're going boom, boom, boom in here. Then I'm doing boom, boom, boom in there. Let's see. So we're doing 0. Oh, that's not good. Let's see, half is equal to. Just do half. I could just pop them afterwards, which is pretty complicated what I'm doing online. I'm probably overcomplicated. I do half. Done. I don't need to do all that. I don't need to do all that. I don't need to do all that. I could just do. I could just do. S. Thing is, it's now immutable. So right now, let me get my thought process straight. I'm getting the first half of them. Let's assume that they're. That's not good. So if I go through the first half of them and I see one that is not over here, right? Let's see if if that character is not in the opening, then we return false. Too early, right? So the thing that I'm realizing about push or like stacks in general is that you can keep track of what and what.
Hey everybody, welcome. In this episode, we're going to go hands-on with
Okay,
stacks
so
and cube.
I think it's possible to solve this without stacks, or I'm using stacks without realizing. So let me close detected. So if that character is not in the opening portion and we're at the first portion of the first half of the portion, then it's not good, right? If that's not the case, then we're gonna keep on going the loop, right? And we want to like push it, right? Because the index, the way I set it up is the way the index of this one is the same index as this one, and then this one, this one. So when I'm appending, because right now we're doing 0, 1. Ah, I see how I did. I inversed it. I inversed it on accident. So type shit. Okay. But yeah, the thing is, it's supposed to be like that on the left side. Because look, do. I didn't inverse it. But it doesn't matter. So let's say in this case it's 6. 6 divided by 2 is 3. 0, 1, 2. Convenient, yes. Now I need to check. So look. Every open bracket is closed by the same type of bracket. So we want to find out what that index is. All right. So boom. So if this goes by, then we know that everything is they're all open, right? Now what needs to be checked is the position in which the closed are. So I could do a dictionary. Right? I could say like, oh, if the second portion, right? We can pop it, right? We could do x dot append that character, that s character, right? And then we do so that means it is empty. If s, sorry, nice. Probably not using this. I'm gonna go bring that up. But yeah, I'm thinking of doing a dictionary because then I could just do shit. So I'm gonna do dictionary. So if I do like dict, so if I say over here, this is going to be equal to this. That is so weird. This is going to be equal to this. This is going to be equal to this. Right? Interesting. Okay. So we're gonna append it to X. Now, this is where the juicy part comes in, right? Technically, this needs to be equal to Interesting. So we have boom, close detected. We have this. We got the character. Now I need to compare it to a dictionary. So what I'm thinking about is now I see the first value pop. Oh, I just thought of something. We append that to the X, right? And then we do for every parenthesis in X, we want to essentially append. We can do let's say for example the first one is going to be that. So, no, we want to go to the last one. I'm going to pop it as we go. What I'm thinking about doing is we have these three, right? I want to make it so I go this one is equal to the key. This value, I'm going to find what's a corresponding to that value, which is going to be this. I'm going to take this value and append it into the list. Man, this is really complicated. I feel like I could have made it way simpler. Submissions. Ooh, I'm having yo, what is this? I'm having the biggest deja vu of my life. Whoa. Okay, I have to relax. Life is not real. So, parenthesis, right? For every value in the parenthesis. The first one we know. We want to put it, append it, then we append. So, let's say we append this value, then we append this value, other value. That's good. So we're gonna do for every parenthesis, we want to check its inverse. So pair is going to be equal to for every I. This is way too confusing. So pair is going to be equal to I. So we're gonna do R. That's gonna set the value though. It's not what I want to do. Let's find the value to that. I'm losing my mind. Parenthesis I. So the first one's gonna be this, it's gonna be this. So it's gonna say pair, and I'm gonna do pair dot append. So it's gonna do. We don't want that. We want dot. So I'm gonna do in range reverse. I could just do that. In range reverse. So we're gonna do reverse. So we're gonna do from length of x reverse. So we're gonna do to -1. we are going to this, n plus 1. So this here we go step of minus 1. We're going to do x at I. Oof. So now that we have that pair, you want to do x dot append that pair value into the list, and then we're gonna print x. Oh yeah, minus 1. All right. Why did it print it twice? Did I select a print? Okay, I see. Beautiful. Beautiful. So what if I do this? Beautiful. What if I do this? Beautiful. Okay. So now we have everything. We're going to say if s is equal to x, then we're going to print. So in this case, we're going to return true. Exact pairs. Else they ain't pairs. And false. Let's go. Okay. I'm feeling good now. This one do here. Exact pairs. Perfect. Okay. So I could give a rundown about what just happened here. Turns out it'll still work without this, surprisingly. And yeah, so I can just do x is equal to now for the final part. So we're returning false here. Returning false here and returning true here. We could have some edge cases, but overall it's looking good. Let me try it over here. Eight pairs. Good. Perfect. So now I could just translate this to code. So only thing I need to make sure we get is the parenthesis thing. Let me just do this for simplicity's sake. Okay, I don't even need this right now, surprisingly. What I do need is this. So we have the S, X is equal to the list value of S. And over here we have the empty string. If not S, so if it is empty, we're gonna print return false. I'm assuming if length of S mod 2 is not equal to 0, we're going to return false for every character in range length of S divided by 2. We are going to do if this character not in parenthesis. Then we're gonna return false. All right. And now we are going to basically append that value that we found. I'm going to do for I in range length of S minus 1, or in this case length of X, sorry. I'm going to do minus 1, minus 1, and minus 1. Do pair is going to be equal to the parenthesis X value at that position. We do X at append pair. And quite simply, we just compare. So if S is equal to X, then we're going to return true, or else return false. Wrong answer. I just realized this is not good. This is not good. This is not good. I sold. Bro, why were there examples not like that? I'm gonna really crash out. Open, close, open, close, open, close. So I think the only thing that matters is if the open matches the same order of the closes, which is not true. Open, open, close, close. Solution time! Solution time! Solution time!
Hey everyone, welcome back, and let's
Close,
that parenthesis.
solution
And I'm going to do
time.
that for all three types. So we had the closing bracket. Let's map that to the open bracket and closing curly brace
Why did he do the reverse of what I did?
to the opening curly brace. So these are our three pairs, 1, 2, and 3. Now let's start actually building up our stack and popping from it and just going through every character in this input string. First, let's check if this character is a closing parenthesis. So if this character is in close to open map, that means it's a closing parenthesis. And the reason why is because the keys, every key of this map is always a closing parenthesis. So if this is a closing parenthesis, we want to make sure that our stack is not empty, right? We cannot add a closing parenthesis to an empty stack, and we want to make sure that the value at the top of our stack is the matching opening parenthesis. So let's make sure. So in Python, stack of -1 is the last value that we just added in the stack. Let's make sure that that is the matching open parenthesis that we need. We can get that by taking our map and getting
If
the
stack. What?
make sure that our stack is not empty, right? We
Mm. So if stack. I see. Because if this means it's empty. So if it is, then it means it's true.
cannot add a closing parenthesis to an empty stack, and we want to make sure that the value at the top of our stack is the matching opening parenthesis. So let's make sure. So in Python, stack of -1 is the last value that we just added in the stack. Let's make sure that that is the matching open parenthesis that we need. We can get that by taking our map and getting the character and getting the closing character from it. So we can basically, that's what we're doing. We're passing in the closing curly brace, getting the opening curly brace or whatever where we need. If these match each other, that's good. That means we can pop from our stack and then continue going. If they don't match each other, or if the stack happens to be empty, that means we have to return false, because that means our parentheses don't match, right? Obviously, we know this is not a matching parenthesis. Having just a closing parenthesis to start us off is not matching. Also, this is not matching, right? Having a closing parenthesis with an open bracket, this is not matching. So that's why we would return false. Though if we don't get a closing parenthesis, that's what this condition is for. So if we ended up getting an open parenthesis, we know the rule for having an open parenthesis is we can add as many as we want. So if we get an open parenthesis, we're just going to take that character and then append it to our stack and just keep going. So remember, at the end, once we've gone through every character, we can only return true if our stack is empty. So if not stack, then we can return true. Otherwise, we return false. So this is the solution code for this problem. I hope you understand why we're using a stack data structure, and I hope that this map makes sense. This map is just a little shortcut for us, and I hope
this
that
thing
was
is so
helpful. If it
simple.
was, please like and subscribe.
Please.
Though if
So if this is in that, we're gonna stack.pop. So, missed one. If C in parentheses, right? And we notice that if stack and stack, the last element in that stack, is equal to the parentheses at that position, and we stack.pop. All right. We're just gonna do else. We're gonna return false.
if we don't get a closing parenthesis, that's what this condition is for. So if we ended up getting an open parenthesis, we know the rule for having an open parenthesis is we can add as many as we want. So if we get an open parenthesis, we're just going to take that character and then append it to our stack and just keep going. So remember, at the end, once we've gone through every character, we can only return true if our stack is empty. So if not stack, then we can return true. Otherwise, we return false. So this is the solution code for this problem. I hope you understand why we're using a stack data structure, and I hope that this map makes sense. This map is just a little shortcut for us, and I hope that this was helpful. If it was, please like and subscribe. It supports.
Alright, guys.